July 28, 1944. Hatfield Aerodrome, Hertfordshire. Geoffrey de Havilland Jr. slams the throttles forward. Two Rolls-Royce Merlin engines scream to life. The prototype DH.103 Hornet lurches forward, accelerating like a bullet train made of wood and fury. Within seconds, he's airborne. Within minutes, he'll hit 485 miles per hour in level flight, faster than any fighter. The RAF has ever flown, faster than anything Japan possesses, and a perfect match for Germany's absolute best. But here's the insane part. This aircraft, the fastest piston fighter ever built, will arrive too late for the war it was designed to win. And yet it will become the most beloved fighter of the man who flew more aircraft types than anyone in human history. Before we dive into this incredible story, don't forget to hit that subscribe button and turn on notifications so you never miss our next deep dive into the forgotten legends of military history. Join our community of history enthusiasts as we uncover the untold stories, the overlooked heroes, and the engineering marvels that changed warfare forever. Trust me, you won't want to miss what's coming next. This is the story of a wooden miracle built by a small team. In 13 months, an aircraft so advanced it embarrassed every competitor and a fighter that never fired a shot in the war. It was built for, but ended up fighting a completely different conflict on the other side of the world. The man at the center of this story, Ronald Bishop, a quiet engineer who designed the Mosquito and decided to do it again, only better. Let me take you back to 1943. The war in Europe is grinding Germany into dust. RAF Bomber Command and the U.S. 8th Air Force are hammering German cities night and day. The Mosquito de Havilland's wooden wonder is outrunning every Luftwaffe interceptor and dropping 4,000-pound bombs on Berlin from 25,000 feet. But the Pacific. The Pacific is a nightmare. Japan controls an empire stretching across thousands of miles of ocean. American B-29 superfortresses can reach the Japanese home islands from forward bases, but their fighter escorts cannot. The distance is simply too far. Every single engine fighter runs out of fuel before completing the round trip. Bombers are getting slaughtered by Japanese interceptors. Crews are dying. The mathematics of fuel versus weight versus performance has created an impossible problem. You can build a fighter that's fast enough to fight, or you can build one with enough range to escort bombers across the Pacific, but you cannot build both, or so everyone thought. The RAF is assembling Tiger Force, a massive Commonwealth bomber wing equipped with Lancasters and Lincolns, designed for the final strategic bombing campaign against Japan. But Tiger Force needs escorts, long-range, single-seat, high-performance escorts that can fly from island bases to Tokyo and back, while fighting off every Japanese fighter that rises to meet them. In 1942, no such aircraft exists anywhere on Earth. The North American P-51D Mustang. America's best long-range fighter is committed to Europe. The Hawker Tempest has the speed, but not the range. German designs have the same problems. Everyone is stuck in the same trap. Adding fuel means adding weight. Adding weight means losing performance. You arrive over the target too slow to survive, or you never arrive at all. Fighter pilots are calling it the Pacific death sentence. But there's another way. Twin-engine fighters can carry enough fuel for the distance and still have power to spare. The Mosquito proved that twins could match single-engine fighters for pure speed. But the Mosquito was designed as an unarmed wooden bomber and then adapted to other roles. It has a two-man crew chin radiators that add drag and a thick wing inherited from its bomber origins. What's needed is a Mosquito designed from the first rivet as a single-seat fighter. Smaller, cleaner, faster, with every aerodynamic compromise stripped away. The problem: nobody thinks it's possible. Enter Ronald Bishop, chief designer at de Havilland, the brilliant mind behind the Mosquito, and a man who absolutely refuses to accept impossible. In autumn 1941, with the Mosquito in full production and spare capacity in his design office at Hatfield, Bishop starts sketching. His first attempts go nowhere. The DH.101 and DH.102 designs call for Napier Sabre or Rolls-Royce Griffin engines, but both programs are oversubscribed. Napier can't free up sabers for a private venture. Rolls-Royce is committed to Griffins for the Spitfire and Firefly. Every door slams shut. Most designers would give up. Bishop goes back to first principles and asks Rolls-Royce a question nobody has asked before: can you make the Merlin smaller? The answer changes everything. By repositioning the Merlin's auxiliaries, the Magneto's intercooler and oil pump, Rolls-Royce can reduce the engine's frontal area significantly. Combined with redesigned cowlings, they create the slimline Merlin 130 and its mirror image partner, the Merlin 131. Each produces 2,070 horsepower in a far cleaner installation than anything previously fitted to a British aircraft. But here's the genius part. The Merlin 131's propeller turns the opposite direction to the 130. This solves a problem that has plagued every twin-engine fighter ever built. Two propellers turning the same direction generate asymmetric torque that pulls the aircraft sideways on takeoff and makes single-engine flight a constant wrestling match. Handed propellers cancel that torque almost entirely. The aircraft flies as if it were a single-engine design with twice the power. Bishop's small team at Hatfield knows exactly what they're doing. C.T. Wilkins handles detail design. C.C. Walker, de Havilland's chief engineer and one of the founding directors, signs off on structural choices. Jeffrey de Havilland Jr., son of the firm's founder, will do the test flying himself. Together, they've already produced one of the fastest combat aircraft of the war. Now they're going to exceed it. In June 1943, the Air Ministry finally commits. Specification F.1/43 is written around Bishop's design. A contract for 2 prototypes is placed. The aircraft is named Hornet. Bishop's team has 13 months from contract award to first flight. 13 months to build the fastest piston fighter on Earth. They build the fuselage using the same concrete molds as the Mosquito. Balsa wood core sandwiched between 2 layers of birch plywood, light and strong and remarkably aerodynamic. But the wing is something revolutionary. For the first time on any production aircraft anywhere in the world, the Hornet's wing combines wood and metal in a single bonded structure. Internal ribs and spars are wood. The upper skin is stressed birch plywood, taking flight loads and compression. The lower skin is a single sheet of alclad aluminum, taking the same loads in tension. Holding them together is Redux 775, a phenolic formaldehyde adhesive developed at Duxford in 1941 and never previously trusted with primary aircraft structure. Engineers call it insane. Bishop calls it necessary. The result is extraordinarily clean, a thin laminar flow wing with radiators built into the leading edge, where they cost almost no drag at all. July 28, 1944 arrives. Jeffrey de Havilland Jr. settles into the cockpit of prototype RR915. He opens the throttles. The Hornet behaves like the thoroughbred it was bred to be. The undercarriage initially refuses to retract, and the tail buffets in cruise, but both problems are solved within weeks. By September, the prototype has logged 50 hours and is demonstrating speeds the original team thought optimistic. A second prototype joins trials in early 1945. The numbers tell an incredible story. Production Hornet F3 reaches 472 miles per hour at 22,000 feet. Initial rate of climb tops 4,500 feet per minute. Service ceiling is 35,000 feet. Range with 2 200-gallon drop tanks exceeds 2,500 miles. Armament is 4 Hispano Mark V cannon under the cockpit, each fed with 190 rounds, plus underwing stores of 2,000-pound bombs, or 8 rocket projectiles, against the Mosquito fighter bomber. Mark VI, the closest predecessor the Hornet, is 60 miles per hour. Faster while carrying heavier armament. Against the Hawker Tempest, Mark II, the RAF's hottest single-engine fighter. The Hornet is 20 miles per hour faster, climbs harder, and has 3 times the range. Against German aircraft, the comparison is devastating. The Focke-Wulf Ta-152H, Germany's last word in piston fighters barely matches the Hornet's top speed using both nitrous oxide and water methanol injection at extreme altitudes where it can barely fight. The Dornier DH.103 could nominally exceed the Hornet, but only 13 production examples were delivered before Oberpfaffenhofen was overrun, and none ever became properly operational. Against American equivalents, the same picture emerges. The Lockheed P-38 Lightning is 100 miles per hour slower. The Grumman F-7F Tigercat is 30 miles per hour slower with similar armament. But here's the tragedy. Nobody saw coming by August 1945. The Pacific War is over. Tiger Force, the operation that should have been the Hornet's first action, is disbanded on October 31, 1945, before any Hornet squadron stands up. The aircraft designed to escort bombers all the way to Tokyo never fires a shot in the war. It was built to win. 13 months of brilliant engineering, revolutionary construction techniques, and speed that embarrasses every competitor, all arriving too late. Most aircraft would end here scrapped as obsolete before they ever prove themselves. Most stories would end in failure, but the Hornet story is just beginning. Because while the Pacific War ended, another conflict is about to explode on the other side of the world, and the fastest piston fighter ever built is about to find its true purpose in the most unexpected place imaginable. In Part 2, we'll see how this wooden marvel designed for high-altitude combat over the Pacific ends up fighting a brutal jungle war, setting speed records that stand for decades, and earning the eternal devotion of the most experienced test pilot in human history. What happens next will shock you. The fastest piston fighter ever built arrives too late for the Pacific War. Tiger Force disbanded. Japan surrendered. 13 months of brilliant engineering wasted. But wait. Because in 1946, while politicians celebrate peace, something catastrophic is brewing 8,000 miles from London, and the Hornet is about to prove its worth in ways nobody imagined. The aircraft enters RAF service with 64 Squadron at RAF Horsham St. Faith, near Norwich in 1946. Then 19 Squadron at Wittering. Then 65 Squadron at Church Fenton. By 1948, 4 squadrons are flying Hornets from Eastern England bases. Fast, beautiful, and absolutely useless. Why? Because the enemy they were built to fight no longer exists. Soviet jets are faster than any piston fighter could ever be. The Hornet sits on British runways, the fastest thing with propellers in the entire RAF inventory, searching for a mission that makes sense. Senior commanders whisper the obvious question, why keep producing an obsolete aircraft? Why waste resources on yesterday's technology when jets are the future? Then 1948 explodes. Ethnic Chinese communist insurgents launch an armed rebellion against British colonial authorities in the Federation of Malaya. The conflict known as the Malayan Emergency turns brutal fast. RAF, Far East Air Force, opens the campaign with Spitfires Beaufighters and Bristol Brigands. All 3 are dying. Spitfires are too short-ranged for jungle patrol. Beaufighters are too slow. Brigands are killing their own crews through engine failures and structural problems over hostile terrain. Pilots are terrified of their own aircraft. Between 1949 and 1951, Far East Air Force loses more aircraft to mechanical failure than to enemy action. The Communist Malayan National Liberation Army controls vast jungle territories. RAF strikes are hitting empty camps because single-engine fighters cannot loiter long enough to coordinate with ground forces. By the time Spitfires arrive over target zones, the enemy has vanished into vegetation so dense you cannot see 10 feet. Air Vice Marshal Francis Fresanges, commanding Far East Air Force, faces an impossible problem. He needs aircraft that can patrol for hours over jungle, carry enough firepower to destroy bunker complexes, and never suffer single-engine failure over hostile territory, where bailout means torture and execution. Every aircraft he has fails at least one criterion. The Spitfire has the performance, but not the range or reliability. The Brigand has twin-engine safety but keeps falling apart. Nothing works. Casualties mount. The insurgency spreads. London demands results. Then someone mentions the Hornet. Fressanges reviews the specifications and realizes he is looking at the perfect jungle fighter, nobody designed for jungles. Twin Merlin engines for absolute reliability. 4 20mm cannon and 8 rocket projectiles for bunker-busting firepower. 2-hour loiter time over target areas for coordinated strikes with ground forces. And speed, that means, if things go wrong, his pilots can run. The Hornet was built for high-altitude combat over the Pacific. It is about to fight a low-level counterinsurgency war in equatorial heat and humidity that will destroy wooden aircraft. 3 squadrons convert. 33 Squadron takes Hornets in 1951, replacing Tempests. 80 Squadron follows operating from Hong Kong and Malaya. 45 Squadron at RAF Tengah, Singapore, exchanges its Nightmare Brigands for Hornet F-3S in 1952. Pilots who have been genuinely afraid of their previous mounts find themselves flying the fastest single-seat fighter the RAF ever sent east of Suez. The difference is immediate. Hornets can cruise at 300 miles per hour to the target zone, throttle back and circle for 2 hours, while forward air controllers on the ground identify communist camps hidden under triple canopy jungle. When they spot something, the Hornet pilot rolls in, with 4 cannon blazing, and 8 rockets ripple firing into bunker complexes that Spitfires could barely scratch. The wooden wings and bonded redux structure that engineers worried would rot in tropical humidity simply work. The handed Merlins that were designed to cancel torque at 20,000 feet over Japan are preventing single-engine emergencies over Malayan jungle, where engine failure means death. 45 Squadron alone flies approximately 4,500 operational sorties over 5 years. 33 Squadron, beginning with Tempests in 1949 and converting to Hornets in 1951, accumulates around 6,150 sorties before withdrawal. Across Far East Air Force, the Hornet becomes the workhorse of the air war against communist insurgents. Pilots describe it as the aircraft that makes them feel safe, fast enough to escape ground fire, reliable enough to trust over hostile terrain, powerful enough to obliterate targets that other aircraft merely damage. The communist forces have no answer. Their anti-aircraft capability is primitive. Their fighters are non-existent. What they face is an aircraft designed to dogfight Japanese Zeros at 470 miles per hour, now dropping 2,000-pound bombs on jungle camps at treetop level. But the Hornet's reputation is being built somewhere else entirely, by someone who will define its legacy forever. Captain Eric Brown, known throughout the Fleet Air Arm as Winkle is flying everything. According to official records, Brown flies 487 different aircraft types during his career, more than any human in history before or since. German jets captured in 1945, American Sabres in Korea, every British piston fighter from Hurricane to Sea Fury, the Mosquito in a dozen variants. He has the experience base to judge what matters and what does not, and he picks the Hornet. Brown's deck landing trials of the prototype Sea Hornet aboard HMS Ocean in August 1945 are so smooth that no crash barrier is rigged. He lands the prototype with absolute confidence, stark contrast to most carrier evaluations where new aircraft are expected to crash. The Sea Hornet, the navalized variant with folding wings and strengthened undercarriage, enters Fleet Air Arm service with 801 Naval Air Squadron at RNAS Ford on June 1, 1947. They embark HMS Implacable and later HMS Indomitable. For the Royal Navy, this is revolutionary, a twin-engine single-seat carrier fighter that handles like a single-engine hot rod. Summer, 1948. 3 Sea Hornet F-20S from 806 Naval Air Squadron deploy across the Atlantic on HMCS Magnificent to demonstrate at the International Air Exposition in New York. Their routine includes the aerobatic sequence Brown has perfected dive at full power feather. Both propellers loop the aircraft as a glider, then unfeather at the bottom of the maneuver. American crowds watch a British twin-engine fighter pulling vertical maneuvers that single-engine American types cannot match. The diplomatic impact for British aviation in the immediate post-war years is enormous. 809 Naval Air Squadron. The only frontline night fighter unit becomes part of the Fleet Air Arm's first all-weather air group in May 1951, with Sea Hornet NF-21s equipped with ASH radar. Brown describes flying the Hornet as like flying a Ferrari in the sky, a tuned-up hot rod version of the Mosquito. Most twin-engine fighters are obviously underpowered on single engine. The Hornet can do almost everything on one engine that it does on two. In Air International magazine, October 1982, Brown writes that aerobatics in the Sea Hornet are absolute bliss. Maneuvers in the vertical plane can only be described as rocket-like. Even with one propeller feathered, the Hornet loops with the best single-engine fighter. Test reports from the Aeroplane and Armament Experimental Establishment at Boscombe Down repeatedly single out roll rate as exceptional. For a twin of its size and weight, the Hornet rolls at speeds comparable to dedicated dogfighters half its mass. The last operational Hornet sortie is flown May 21, 1955, by a 45 Squadron aircraft over Malayan jungle. By mid-1956, the type is withdrawn from RAF service entirely. The Sea Hornet already gone replaced by the de Havilland Sea Venom jet in 1954. The Hornet is the last RAF piston engine fighter in frontline service. 8,000 horsepower. 472 miles per hour. Loved by every pilot who flew it. And completely obsolete. But here is what nobody expected: the wooden aircraft built in 13 months for a war it never reached. Fought a jungle counterinsurgency for 9 years. Set point-to-point speed records performed at international air shows, and earned the eternal devotion of history's most experienced test pilot. In Part 3, we will see how this miracle nearly vanished forever, and why today only one restoration project stands between the Hornet and total extinction. 9 years. 45 Squadron flies 4,500 operational sorties. 33 Squadron racks up 6,150 missions. The fastest piston fighter ever built dominates Malayan skies. Communist insurgents have no answer. But while Hornets rule the jungle, something else is happening. Something nobody talks about. The aircraft designed to last a decade is dying. Wood and tropical humidity are natural enemies. The Hornet's fuselage is balsa and birch plywood bonded with redox adhesive. Its revolutionary wing combines wooden structure with aluminum skin. Both were engineered for temperate European climates, not equatorial heat that reaches 100 degrees with 90% humidity. By 1952, maintenance crews at RAF Tenga are fighting a losing battle. The redox bonds absorbing moisture, plywood layers delaminating, wooden spars swelling and contracting with temperature cycles. Every inspection reveals new cracks, new separations, new warnings that the structure is degrading faster than anyone predicted. Squadron commanders file reports. The wooden wonder is rotting from the inside. Engineers estimate 5 years maximum service life in tropical conditions before catastrophic structural failure becomes probable. Some Hornets are already approaching that limit. The Air Ministry faces an impossible choice: ground the entire Far East fleet for expensive rebuilding, or keep flying and risk pilots dying when wings separate in flight. They choose neither. They choose replacement. By 1955, jets are flooding RAF inventory. The Venom, also built by de Havilland, offers similar performance without wooden structure worries. The decision is made. Withdraw the Hornet. May 21, 1955. A 45 Squadron Hornet lifts from RAF Tenga for the last operational sortie. 2 hours over Malayan jungle. 4 cannons silent, because there are no targets. The pilot lands, shuts down the Merlins, and walks away. 9 years of combat operations end not with dramatic finale, but administrative efficiency. By mid-1956, every Hornet is withdrawn from RAF service. The Sea Hornet gone even earlier, replaced by Sea Venoms in 1954. The last frontline piston fighter in RAF history retires to storage hangars across Britain and the Far East. Then comes the massacre. Tropical storage has destroyed the wooden airframes beyond economical repair. Humidity has penetrated every bonded joint. Redux adhesive that held revolutionary wing structures together has failed. Plywood skins are delaminating. Balsa cores are crumbling. Metal components are corroding from moisture trapped in wood. The aircraft are not just obsolete, they are disintegrating. Between 1956 and 1957, scrapping begins. Hornets are broken up at Seletar in Singapore at maintenance units across Britain at every station where they were stored. The wood burns easily. The metal goes to recycling. 383 aircraft built. Within 2 years of retirement, almost all are destroyed. Nobody saves them. Why would they? Jets are the future. Piston fighters are yesterday's technology. Museums have Spitfires and Hurricanes representing the Battle of Britain. They have Lancasters representing Bomber Command. What does the Hornet represent? An aircraft that arrived too late for World War II and fought a colonial counterinsurgency nobody wants to remember. The fastest piston fighter ever built vanishes into scrapyards and bonfires with barely a memorial. Captain Eric Brown watches this happen with growing horror. The man who flew 487 different aircraft types more than anyone in history has declared the Hornet his absolute favorite piston engine aircraft. Not the Spitfire, not the Mustang, not the Sea Fury, the Hornet. And they are burning them. In interviews through the 1960s and 70s, Brown repeatedly praises the aircraft. In October 1982, he writes for Air International magazine describing Sea Hornet aerobatics as absolute bliss vertical maneuvers, as rocket-like single-engine performance exceeding most twins on both engines. Brown's party trick at the 1948 New York International Air Exposition diving at full power, then looping the Hornet as a glider with both propellers feathered, becomes aviation legend. He tries to generate interest in preservation. Nobody listens. By 1960, perhaps 20 Hornets survive intact worldwide. By 1970, maybe 10. By 1980, fewer than 5. The attrition is relentless. Wooden structures exposed to weather collapse. Aircraft stored outdoors deteriorate. Even indoor storage cannot prevent slow decay without climate control. Redux bonds continue failing. Plywood continues delaminating. What the RAF could not destroy through 9 years of combat operations, time and neglect, finish in 2 decades. New Zealand becomes the final hope. Pioneer Aero at Ardmore Aerodrome acquires Sea Hornet. TT-193, a target tug variant that survived slightly better than fighters because it was retired earlier and stored more carefully. The fuselage is remarkably complete. Wings are present but damaged. Both Merlin engines are missing. The cockpit has been stripped. What remains is a wooden skeleton of what was once the fastest twin-piston fighter ever to reach operational squadrons. Pioneer Aero begins restoration work in the 2000s. Progress is agonizingly slow. Every wooden component must be assessed, repaired, or rebuilt. Redux bonded structures require specialized knowledge that barely exists anymore. Original drawings are incomplete. Photographs are scarce. The restoration team faces problems de Havilland's engineers never imagined. How do you source Redux 775 adhesive that has not been manufactured since the 1950s? How do you rebuild bonded wood, metal wing structures when nobody alive remembers the original technique? How do you restore plywood fuselage sections when the original molds were destroyed decades ago? Every question leads to research experimentation, failure adjustment. Years pass. TT-193 remains disassembled across multiple workshops. In Britain, a single Hornet F-1 fuselage section survives painstakingly reconstructed from scrap remains. It sits in a private workshop, never to fly, representing 383 aircraft that once dominated RAF squadrons. That is the entire physical legacy. one fuselage section. One restoration project decades from completion. No flying examples. No complete museum displays. The fastest piston fighter the RAF ever flew exists as scattered components and fading photographs. But the numbers tell a different story. 472 miles per hour in service condition. Faster than the Mosquito by 60 miles per hour. Faster than the Tempest by 20. Faster than the Focke-Wulf Ta-152H without nitrous injection. Faster than the Grumman Tigercat by 30. Matched only by prototypes that never reached operational squadrons. The production, Hornet F-3, the aircraft that actually flew combat sorties and set speed records and performed at air shows, was definitively the fastest twin-piston fighter to achieve frontline service anywhere in the world. Eric Brown's verdict stands unchallenged. The man who flew more aircraft than anyone in history picked the Hornet. He described it as a Ferrari in the sky, a hot rod version of the Mosquito, an aircraft that could loop on single engine, an aircraft where deck landing trials aboard HMS Ocean required no crash barrier because he had absolute confidence it would behave. Brown flew German jets and American Sabres and every British piston fighter from Hurricane to Sea Fury. He chose the Hornet. The engineering was revolutionary. First production aircraft anywhere to combine wood and metal in bonded primary structure. First to use redox phenolic formaldehyde adhesive in load-bearing applications. First British fighter with handed propellers eliminating asymmetric torque. Wing radiators built into leading edges costing almost no drag. Laminar flow wing profile borrowed from Mustang playbook. Slimmed Merlin installations repositioning auxiliaries for reduced frontal area. 13 months from contract award to first flight. Ronald Bishop and his small team at Hatfield producing an aircraft that embarrassed competitors with 10 times the resources. The combat record was unexpected. Designed for high-altitude escort over the Pacific. Actually fought low-level counterinsurgency over Malayan jungle. 4,500 sorties from 45 Squadron alone. 6,150 from 33 Squadron. Pilots who were terrified of Bristol brigands finding themselves confident in Hornets. Twin Merlin reliability preventing bailouts over hostile terrain. 4 cannon and 8 rockets demolishing bunker complexes. 2-hour loiter time coordinating with ground forces. The Communist Malayan National Liberation Army had no counter. The fastest fighter in RAF history was dropping bombs at treetop level on targets nobody imagined when drawing the first blueprints. Today, Pioneer Aero continues restoration work on DH.103. Whether that aircraft ever flies again remains uncertain. The technical challenges are enormous. The financial requirements are brutal. The expertise is scarce. But if successful, one Hornet will return to the sky representing an aircraft that proved British engineering at its absolute peak. Faster than anything that came before. Loved by everyone who flew it. Gone from history within a generation. In Part 4, we examine the final chapter, what the Hornet means for aviation history, why its story matters today, and the lessons from an aircraft that arrived too late for the war it was designed to win, but became the definitive word on piston engine fighter design. The conclusion will surprise you. From revolutionary prototype to jungle warrior to scattered wreckage. 383 aircraft built. 9 years frontline service. Then almost total extinction. But the story of the fastest piston fighter ever built has one final chapter nobody talks about. Because sometimes the price of being too good is being forgotten. Ronald Bishop never saw the Hornet's combat record. The chief designer who created both the Mosquito and its faster, deadlier successor died in 1989, aged 78, having watched his wooden marvel vanish from aviation history within a generation. He gave interviews occasionally, always modest, always deflecting credit to his team at Hatfield. C.T. Wilkins handled detail design. C.C. Walker approved structural choices. Jeffrey de Havilland Jr. did the test flying. Bishop was just the man who asked Rolls-Royce if they could make the Merlin smaller. That single question led to handed propellers, slimmed cowlings, wing-mounted radiators, and an aircraft that hit 472 miles per hour in service configuration. Bishop never boasted. He simply designed two of the fastest piston aircraft ever flown, then retired quietly while jets took over. Jeffrey de Havilland Jr., the test pilot who first flew the Hornet prototype on July 28, 1944, did not live to see retirement. He died September 27, 1946, testing the DH.103 Swallow de Havilland's experimental swept-wing jet. The aircraft broke up in a high-speed dive over the Thames estuary. De Havilland was 26. He had flown the Mosquito to its limits, pushed the Hornet through trials that proved every specification, and was exploring transonic flight when aerodynamic flutter tore his aircraft apart. The man who proved wooden fighters could match anything in the sky died, proving jets were the future. His Hornet, the aircraft he described as smooth and responsive beyond anything he had flown, outlasted him by 9 years of combat service he never witnessed. Captain Eric Brown, the Fleet Air Arm test pilot who called the Hornet. His favorite piston aircraft lived to 97. He died February 21, 2016, having spent 70 years telling anyone who would listen that the Sea Hornet was absolute perfection. Brown flew 487 types: German jets, American fighters, Soviet bombers, every British design from Hurricane to Harrier. He picked the Hornet. In interviews late in life, he remained adamant. The aircraft could loop on single engine. It could glide with both propellers feathered and recover. It handled on carrier decks with confidence he never felt in other twins. Brown's obituaries mentioned his world record for carrier landings and his capture of German aircraft in 1945. They rarely mentioned the Hornet. Even the man who loved it most could not keep it in public memory. But the legacy is deeper than recognition. The Hornet proved something fundamental about aircraft design. Twin-engine fighters do not have to be heavy, sluggish compromises. With correct engineering, they can match single-engine performance, while offering reliability, range, and payload single-engine designs cannot approach. The handed propeller configuration Bishop pioneered became standard on every serious twin-engine design afterward. Counter-rotating props eliminate asymmetric torque. They transform handling. Every modern twin-engine aircraft, from the Beechcraft Baron to the Lockheed P-38 Lightning's late variants to the modern Diamond DA-42, uses the principle the Hornet demonstrated. What was revolutionary in 1944 is now foundational. The bonded wood-metal wing structure was different. Redux 775, adhesive holding wooden ribs to aluminum skins, represented aerospace engineering at its most ambitious. It worked spectacularly for a decade, then failed spectacularly in tropical storage. No major aircraft manufacturer attempted wood-metal bonding again. The lesson was clear. Revolutionary construction techniques must survive operational environments, not just performance trials. Modern composite materials, carbon fiber bonded to aluminum or titanium, echo the Hornet's ambition, but use adhesives and materials engineered for durability Bishop never had access to. The principle endures. The execution evolved. The combat record tells its own story. 45 Squadron flew 4,500 operational sorties over Malaya between 1952 and 1955. 33 Squadron accumulated 6,150 sorties. 80 Squadron operating from Hong Kong and Singapore added thousands more. Across Far East Air Force, Hornets flew an estimated 15,000 combat missions, destroyed hundreds of communist bunker complexes, supported countless ground operations, and lost 0 aircraft to enemy action. Not one Hornet was shot down by hostile fire during the Malayan Emergency. Twin Merlin reliability meant no pilots bailed out over jungle, where capture meant execution. 4 cannon and 8 rockets meant targets were obliterated, not merely damaged. 2-hour loiter time meant coordination with ground forces that single-engine fighters could not achieve. The aircraft, designed for high-altitude escort over the Pacific, became the perfect low-level attack platform over equatorial jungle. Nobody predicted that. Bishop certainly did not design for it. but engineering excellence transcends original intent. The speed records stand unbroken in their category. September 15th, 1949. Flight Lieutenant H. Peebles flew Bovington to Gibraltar at 357 miles per hour average. 3 days later, Group Captain A. P. C. Carver flew the return at 435 miles per hour. October 16th, 1951. 4 Sea Hornet night fighters covered Gibraltar to Lee on Solent in 3 hours, 10 minutes averaging 330 miles per hour. These are not historic curiosities. They are proof that piston fighters reached performance levels jets struggled to match in early service. The Vampire jet that replaced the Hornet in RAF squadrons was barely faster. The Sea Venom that replaced the Sea Hornet in Fleet Air Arm Service had similar range and payload. Jets won because they had development potential, not because early jets were superior. The Hornet represented the absolute ceiling of piston technology. It arrived at that ceiling precisely when the ceiling became irrelevant. Today, Pioneer Aero at Ardmore continues restoration of Sea Hornet TT-193. Progress is measured in years. Every wooden component requires assessment repair or complete reconstruction. Redux 775 is no longer manufactured. Original construction techniques are documented in scattered photographs and incomplete drawings. The team is essentially reverse engineering a bonded wood metal structure from a 70-year-old airframe that was already degraded when they acquired it. If successful, one Hornet will fly again. One aircraft representing 383 built 15,000 combat sorties flown and the definitive achievement of British piston fighter design. The odds are long. The effort continues. But here is what almost nobody knows. When the last operational Hornet retired in 1956, de Havilland, Canada, was already designing the DH.103 Beaver, a wooden bush plane that would become legendary for reliability in harsh conditions. Several engineers who worked on Hornet production transferred to Canadian operations. The Beaver's wing construction techniques, its approach to bonded wooden structure for lightness and strength, its focus on twin-engine redundancy, adapted to single-engine format, all echo lessons learned from Hornet experience. The wooden fighter that rotted in tropical storage influenced the wooden bush plane that thrived in Arctic conditions. Engineering knowledge transfers in unexpected ways. The Beaver flew for decades. Hundreds remain in service today. The Hornet's structural lessons, refined and adapted, continue working 70 years later in aircraft whose pilots never heard the name. From a quiet engineer asking if Rolls-Royce could slim the Merlin to 13 months of focused development to an aircraft that hit 472 miles per hour and embarrassed every competitor to 9 years of jungle combat. Nobody predicted to near total extinction, to one restoration project keeping the dream alive. Ronald Bishop proved that small teams with clear vision can outperform massive organizations with unlimited resources. The Hornet was faster than anything that came before it in RAF service. It was loved by everyone who flew it. It changed counterinsurgency warfare in ways its designers never imagined. And it vanished from history so completely that most aviation enthusiasts today have never heard its name. That is the price of arriving too late for the war you were built to win, then proving your worth in a conflict nobody wanted to remember. The fastest piston fighter ever built deserves better. Perhaps this story helps. Perhaps Pioneer Aero succeeds and one Hornet flies again. Perhaps not. But the engineering, the combat record, and the testimony of the greatest test pilot in history are facts. The de Havilland Hornet was everything they claimed and more. Remember it.